All right, so here we go with the last part of section 7.1, Venn diagrams. And so what we're going to take a look at here is how we could use Venn diagrams to talk about those things we were just talking about, intersections, unions, and complements. All right, so first off, what is a Venn diagram? Well, a Venn diagram is a visual tool for displaying sets, operations of sets, and we're going to use them for probabilities, and we're going to use them for counting, use them for a lot of things. But basically what they are is they're a picture we can draw that can show a relationship between sets. For example, in this first one right here, I'll highlight it in green. This one right, whoa, not in black, huh? I want green highlighter. In this one right here, we are taking a look at a picture where I have a universe, or the universal set, defined by the box on the outside. So that U right there tells me that this box represents my universe. I have a set A, and that's the circle drawn on the left. I have a set B, and that's the circle drawn on the right. And then I have that piece in the middle that is shaded green. And so that piece in the middle that's shaded green, that's where we have elements that are inside and our set A, as well as inside our set B. That would be A intersection B. And it's just a visual way to show a relationship between the sets, their intersection, and the universe. Using that same logic, what's happening down here in the second one? What's happening here? Right? Well, down there we're taking a look at a universe, a set A, and a set B, but the chunk that's shaded now is everything that is inside of set A, or inside of set B, or inside of both of them there in the middle. So that blue area there in the middle there, that would be the A union B in a Venn diagram. All right, chasing that same logic, what's happening here in this one? Well, it looks like I've got a universe because I've got a box. I've got an A, and I've got that A complement. So the shaded area outside of A is everything that's inside of U, but outside of A, so that would be the complement of set A. And then the last one down here, what's this picture showing? Well, it's showing a universe. It's showing a set A on the left, and it's showing a set A on the right. And you notice how there's space in between them, that there's no overlap. Well, that would be a Venn diagram that shows that A and B are disjoint, meaning that they have no elements in common. You could also say this, that A intersection B is equal to the empty set. Okay. All right, so let's erase some of these words, and let's take a look at what this would look like if I were to make up a problem for this. So really quickly, let's say that the universe is the set 1, 2, 3, 4, 5, 6. Let's say that set A is the set 1, 3, 6. Let's say that set B is the set 3, 5, and let's go ahead and properly fill in this first Venn diagram for that information. Now, the fact that the universe contains the set of elements 1, 2, 3, 4, 5, 6, that means that inside of this box over here, I have to place all 6 of those elements. 3, you'll notice, is in the intersection of those two. So I would put 3 right there. 1 and 6 would go here because they are inside of the set A, but they are not inside of set B. So I would put them in the part of the circle of A that is outside of B. 5 goes over here because it is inside of B, but it is not inside of A, so it's not in the intersection. And then what about the rest of the elements? Like, where does 2 go? Well, 2's out here somewhere. So is 4, because they are elements that are inside of the universe, but not inside of set A, nor inside of set B. And so what I've done here is I've just taken my universe. I've found homes for all of the elements, 1, 2, 3, 4, 5, and 6. And I've placed them according to how those sets A and B were defined. So we can use Venn diagrams as a way to describe sets, to place elements into a picture. And sometimes when things get a little complicated or confusing, we can use the sets here to talk about where things are and what intersections would look like or what unions would look like. All right, so down here, this would be the Ryan Reynolds one. Okay, so the universe was all Ryan Reynolds movies. Set A was the set, what was it? It was good movies. And then set A complement would be all the bad Ryan Reynolds movies. So in here would be Deadpool. That was a good one. And then out here would be, what was that? Was it X-Men Origins? The one where he was in there with Wolverine, he was a Deadpool, and he was horrible. It was absolutely, that was a terrible Ryan Reynolds movie. And I'm sure there would be others in here because I think that there's probably somebody out there who could come up with another Ryan Reynolds movie they thought was good, and maybe another bad one out there. But good ones there, bad ones there, opposite. All right? Disjoint sets. What could we make up for that? Well, we could say that the universe is, oh, I don't know, how about professional sports? Professional sports athletes. And we could say that A is all, I don't know, baseball players. So this is going to be active current baseball players. And B could be the set of all professional, I don't know what, table tennis players. And so now we're saying that here's all the baseball players over here. Here's all the table tennis players over here. Out here would be everybody who's a professional athlete but doesn't play baseball and doesn't play table tennis. And then there's no intersection because, according to Google, there are no baseball players who are also professional table tennis players. All right, I'm going to end this video here because this is the end of 7.1. We'll come back and make another one for section 7.2. Have a great day.